Those provide an opportunity to really get creative and to solve some problems that you haven't seen before.
Oh, geez. That's how good they were. I don't know. What do you think about that metal nails through concrete? Fairly excited. Was it the Structural Engineering Podcast?
Hello, everybody. This is the Structural Engineering Podcast, and that voice you just heard was John Roach.
I'm John Roach, structural engineer at Cannon Design in Buffalo, New York.
Cannon Design is, of course, one of the world's leading A&E firms. They are, in fact, ranked by Fast Company as one of the top 10 most innovative architecture firms in the world.
We are super lucky to talk with John about not only his work with existing structures and vertical additions, but also some of the qualities that make Cannon Design so special. We learned a bit about the training opportunities that Cannon has in place for its employees, as well as some of the guiding principles that guide the design at Cannon.
One quick announcement before we get into it. Zach and I have been working hard to start putting out some episodes that can provide some PDH credit. These episodes are a little longer than usual, and you get to take a test in the end, but we think that quality PDH credits should be freely available, so we're trying to do our best to make that happen. If you're interested in sort of beta testing this new thing, send us an email and mention the state you're in. We'll try to get pre-approval in that state and get you everything you need. Our first PDH episode will feature RLG engineers discussing ICC 500 and storm shelters.
Without further ado, Max, let's get going.
So, John, what type of projects do you mostly work on a day-to-day basis for yourself and then as a company?
So as a company, we worked mostly in the healthcare and education field, and that includes like higher education, K-12, and different library systems, things like that. We also do a fair amount of civic work and corporate commercial, especially corporate commercial interiors. As far as the projects that I've worked on, it really runs the gamut. Pretty large science and technology projects. I've done hospitals, healthcare type settings. I've done residential, corporate commercial, pretty much anything across our spectrum of services.
Is there a type of project that you enjoy the most?
Oh, I don't know. They're all great, right?
It's a loaded question, Max.
Yeah, no, but if I had to pick one, it's probably the science and technology, and maybe that's just because I'm coming off of a really big S&T project, but they're unique in the sense that the user groups are often very different, and there's always something unique about the way the users occupy the building. So you might have to satisfy pretty stringent vibration criteria. There might be something with that generates a magnetic field, and you have to consider what type of reinforcing you have in the building and how that might interfere with the equipment.
So we were going to talk today about a lot of additions and expansions because you have done quite a few with Cannon, especially vertical additions, which are particularly kind of a challenge, right? So in adjacent additions, we have a pretty decent tolerance for unknown because it's not as critical, right? But vertical structures require a pretty thorough understanding of the structure. How do you go through the information gathering process?
Well, it really depends on what information is available at the start. So specifically, I can talk about the vertical addition we did at Penn Medicine, Lancaster General Hospital.
Yeah.
For that particular client, for that particular project, we had very good existing drawings of the existing building and all of the surrounding buildings. So specific to that project, and this isn't unusual when you have a vertical addition, it's a complex that kind of grew organically over the last 80 years. Mm-hmm. So it's, yes, you're adding vertically to one building, but the project touches many individual buildings that are kind of attached in part of a larger complex. So it's getting an understanding first of the building that you're adding onto, and then what's happening around the complex. So in this case, there was a large duct bank that went down an alley between all the buildings that we had to be cognizant of when we were designing the foundations. So it's things like that outside of the scope that you have to consider. If you don't have good information, then it's a matter of doing a lot of field surveys. So a similar project, wasn't quite a vertical addition, but a similar project was something we did at the Natick Mall in Massachusetts, where Wegmans supermarkets wanted to go in and occupy a vacant big box store. I think it was JCPenney. Mm-hmm. And the issue there was, for a grocery store, they needed 150 pounds per square foot for the second floor, but under the code, it was only designed for 75. So we had to go in and double the floor capacity, but nobody was able to find existing structural drawings for this building. So we had to have extensive surveys done to go out and measure all of the steel and photographic documentation. So it really, how you approach a project sometimes depends on the information you have available to you at the beginning.
Is there, the first half of this investigation kind of like a feasibility study in some cases where you're not even sure if this is reasonably possible?
Yeah, so that's actually the next step. Once we had all the documentation, in the case of Lancaster, we knew that the building was designed for future floors. So we knew there was some feasibility there. But the hospital itself, they had asked us to look at their whole campus and find out the objective was to add private patient rooms. So from their standpoint, a vertical addition at this location seemed to make the most sense, but they wanted us to look at other options. And so we did a series of studies for different locations where we could provide additions to the existing hospital complex before settling finally on what they called the Stauffer building for the vertical addition. And then once we had that established, we did a series of studies, building analytical models to find out how far could we push it, how high could we go, because they're a landlocked institution, and they really needed to go as high as they could by zoning right. And so we were asked to look at a model to find out how many floors can we add before it becomes too impractical. And what impractical was, we kind of defined with some criteria. And then based on that, we were able to kind of settle on, okay, it's going to be this number of floors. And that's how we made the decision.
That's pretty cool. And getting to work as an AE firm and understand the implications of going vertical as an architect, and must be pretty awesome to work in that capacity. Now, reading the kind of the documentation you sent over about that project, it talked about doing material testing for columns and that you had to plate them to make some of them stronger. How often on these structures are you doing material testing?
Pretty rare, actually. It made sense for this particular project because we knew that the columns were 830. Well, they were nominally 836 steel, but we weren't sure if what was actually provided in 836 has a pretty good range. So we thought, well, maybe there's a chance that the yield strength is actually a lot higher. And it was, in most cases, which helped out a lot. Could have gone the other way, I guess, but we were willing to take that risk. So it's not something we do a whole lot. Because it is destructive testing and can be disruptive. This project was also unique because we were able to access the columns above the roof. They had stubbed up for future expansion. And so we were able to get coupon samples without disrupting any of the interior spaces. And once we started getting good results from those, then it made sense we could justify going into some other areas that were occupied to do coupon samples as well.
Huh. Yeah, that sounds like it worked out pretty well.
Yeah. Sometimes the surprises actually help you on a project like this.
And that's interesting. I know there are some provisions for steel strength, material strength in the IEBC, right, where you can take some increases. This has been a little while since I've done an older steel project, but they will give you historic ranges of steel.
Sure.
And it can be, But I want to ask some IEBC questions, but not quite yet, I think. We'll get to that in a second. That document just kills me. But anyway, Zach, you want to hit our other one?
Yeah, absolutely. So the more complex a project is, the greater need, I think I've definitely found, to have better communication, if not over-communicate, with all different disciplines. Now, you're very fortunate, like we've already discussed, about being an AE firm. Does that make a big difference for when you're trying to execute some of these more challenging renovations?
Oh, absolutely. And I guess, going back to technology, I guess with technology being what it is, it helps all kinds of coordination, including when we have consultants. And we did on the LGH project. But being able to learn from our colleagues across the firm, it's a huge benefit to us, I think, because it changes how we approach design. And, that's true on the engineering side, for sure. because we're able to, I think, coordinate more effectively when you could just walk down a few desks and talk to your mechanical, plumbing, or electrical colleagues. But I think it also changes the way that we look at design overall, engineering design overall. Having the architects part of the firm and kind of lead our design direction and our design culture. So we have what's called living centered design. It's kind of the ethos of our firm. And what that really means is for all of us to kind of have a heads up look when we're designing a building, and it's something that affects everybody. So from a structural engineer standpoint, it kind of forces us to consider, well, how does what we do impact the end user of the building? And it could be something like the people who maintain the building, the people who operate the mechanical equipment, to the patients that are in the patient towers. So for us, specifically to LGH, the idea of living centered design is, okay, if I'm a patient in this patient tower, what do I want to see? And probably don't want to see a cross brace in front of my window. So it's things like that. As much, well, if I were the patient, maybe I would, but
I was going to say, I would argue it depends on the patient.
Yeah, it really depends on the patient. But but that, so that it's kind of our firm ethos, and it really it impacts how we approach our projects.
I'm curious, and it's not really a software plug, but what do you guys like? How do you coordinate across disciplines? You said you had great resources in the office, and then when you maybe have sub-consultants outside of the office, what sort of tools do you use to make sure everything is flowing smoothly?
Well, there's a lot of different tools that are out there. So specifically on the production side, all of our buildings are in Revit, and all of our consultants who are part of a project are using Revit too. Often in terms of the contracts, we can specify which version of Revit we want or need them to use. So for a fairly simple project, what we'll often do is upload our Revit files on a certain day to a shared site, and each consultant or us, we can download those and link them into our own models for coordination. Alternately, we make use of BIM 360, and we have a master software agreement with Autodesk that we're able to kind of use their resources to help improve our productivity. It's kind of a working relationship that we have with them. So that helps a lot as well, especially developing some innovative approaches to this kind of thing.
Yeah, I was reading an FMI report the other week talking about inefficiencies in the construction industry, and one of the things that they were harping on is that BIM isn't going anywhere, and people aren't maybe embracing it to its full capacity. And especially in smaller projects, not everyone is coordinating in Revit, and there's a lot of efficiency that can be gained by making sure we're linking in B360 and things like this to clash detection. I don't know. But
yeah, we actually started using Revit. We were an early adopter, I think, going back to like 2008, 2009, right when it first kind of came out.
Yeah.
So it initially, Revit wasn't used for everything, but by the time I joined the firm, just a few years later, it was. So we don't do AutoCAD. In fact, we haven't. We don't even maintain our standards in AutoCAD, and haven't for a long time. It's just we found. Just in part the coordination aspect of Revit, but there's a lot of benefits, provided that you approach it with kind of a Revit mentality instead of an AutoCAD 2D mentality. But there's a lot of benefits for it.
Since we're on the topic of talking about Revit and stuff, we've gotten a good amount of questions sent to us from new engineers or engineering students asking about, what level of drafting will they be doing once they kind of join the workforce. For you guys, do you guys have, kind of the traditional drafter that works on projects, or are your engineers also drafting?
It's a bit of a hybrid. We have, within all of the technical groups, structural, mechanical, electrical, plumbing, we have BIM leaders embedded within those groups who, I guess, would fill that role of the traditional drafter. But they're really a lot more than that in our company, in that they maintain the BIM standards for those groups. They kind of shepherd projects from initial kickoff through completion, and help out with probably the more complex modeling that makes all of our heads hurt from time to time. And Beyond that, though, we're typically responsible for doing the Revit BIM modeling for all of our individual projects, which I think is a great thing because as you model something, as you work through a detail, it kind of forces you to think about the rationale behind it and question your own decisions in a good way.
Right.
So the level of drafting that we do is really from the most basic modeling through some of the more difficult and complex detailing.
Yeah, I see it as very beneficial to have the engineers draft, and I'm not good at it, so it's it's a tough.
The thing too is with students that are out there, especially, is at least when I was in college, you could download a student version of AutoCAD or Revit and kind of use that not only for your classwork but just to practice, and it's a nice thing to put on your resume.
Oh yeah.
And even before that, a lot of colleges have different summer courses that they offer to local high school students and things like that. So if for high school students, if they're in a program that their school doesn't offer CAD or drafting, and many do now, but if they don't, a lot of times they can take college credit. It's something that I did actually, and gain a little bit of experience and potentially bang out an easy course ahead of time.
Yeah,
absolutely. Yeah, we had a CAD class in high school, and it was pretty cool. I was more interested in the 3D printer they had, but it was kind of cool to work with both.
Yeah, we've got a few of those too, and they are fun little they're fun tools.
Yeah.
Oh yeah. Max, you just got one, right?
Yeah, we just got one in the office. Company. I don't know why, but it's great. I got to figure out what to do with it. But does Canon do any in-house training on some of the on Revit for people that are coming in maybe that haven't touched it in a while or?
Oh yeah. No, it's a good question. I think a lot of large firms do. We have, so broadly speaking, we have what's called the Canon Academy. And it's our in-house learning center. And most large firms have something like this, which is a good way to get in-house PDH credit or AIA credit, depending on your profession. So within that structure, we have formal Revit classes that exist for training. But whenever we onboard a new employee, our BIM leader will sit down with them for a couple of days of pretty intense training, not only in just the use of Revit, but kind of an introduction to our workflow and our kind of unique, the way that we detail projects and approach projects in Revit.
Yeah, that's beneficial. I think a lot of companies don't really get into the training on the non-technical or things that are looked at as non-technical. Maybe they'll hit whatever their analysis package is, intro to RISA or RAM, but
sure,
skip over the things that are seen as the softer items, maybe.
Yeah, and actually, it's funny because I think that our Revit training is probably, I don't know, I feel like it's more formalized than some of our other training, and it's actually one of our initiatives in trying to formalize what our technical and, if you consider Revit non-technical, that side of the training looks like, and how that structure works, how you evolve from one step to another.
Yeah. Cool. All right. Well, I want to ask my IEBC question.
Oh boy.
I think the question is, how's it work? Well, but
good question.
I'll make it a better one. So we have a couple routes to look at existing structures, right? We have the IEBC, the International Existing Building Code, and then the AISC 41. They kind of work in tandem a little bit. They both have these 3 tiers of modifications. I'm going to ask about working through these documents, and maybe in reference to Lancaster General Hospital. What was the code path for something like this? How do you decide what your route is going to be?
Well, for that project, it was kind of decided for us in the sense that regardless of the code that you're looking at, I mean, you need a stable building, which sounds like an obvious statement, but, as you just kind of alluded to, there's so much language, so many code languages about the level 1 through 3. It's almost easy to lose sight of that. So I think, from Lancaster General, yes, IEBC, Pennsylvania State Code, which at the time was IBC 2009, and of course all the AISC references, etc. But what I think we started with just modeling the existing structure with the new floors. And once we did that, it became very clear that the partially restrained moment connections for the 3-story building we were adding onto weren't going to provide enough strength or stiffness for a 9-story building. So, once we got to that point, it became a question of, okay, now we need to we need to provide a lateral system. And if we do that, then IEBC really kind of goes out the window because it's a whole new thing. And we're designing for code required forces under the current governing code.
Mm-hmm.
So LGH was a pretty clear-cut case. Where it gets a little more nebulous is if we're doing a renovation for an existing healthcare facility or an existing college where maybe we're not adding on. Maybe we're just doing an extensive renovation. So to give you an example of that, there's a local university where we did a gut reno of a building that had a couple of additions put onto it, but those additions were structurally independent. And so clear-cut case, new building, new code. The gut reno, what they ended up doing was knocking out all of the clay tile partition walls. And this building it was steel framed, but it didn't have a defined lateral system. So our best guess was that those click tile walls were acting as shear walls within the building. So once those were gone, then it became a pretty clear cut case that we needed to add new braced frames within the existing footprint. Mm-hmm. So sometimes you kind of have to look at a project outside of IBC and kind of say, well, what's happening with the building itself? What are we doing to it that's changing it? And how does that affect us? Mm-hmm. You could spend a whole lot of time trying to determine if it's a class 1 or 2 based on the area of renovation and all of that. And we do. And it's led to a lot of interesting discussions and questions and head scratching. In some cases it's clear cut, but in other cases it really isn't.
So with the Lancaster Hospital, often foundations are the most inaccessible and unknown components of a renovation. What have you found to be the most effective ways to modify them when you need to improve them in any way?
Well, the most effective way is don't. But if you can't do that, LGH was helpful in that the basement of that building was mainly used for storage. So we kind of had that all to ourselves in terms of doing what we needed to do down there. With foundation modifications, it kind of goes back to what I was saying earlier. You almost have to approach it just from a logical perspective of load paths and say, okay, well, I can't just scab onto my foundation and put a cold joint in there because that, it's really not going to work. It's going to be 2 separate foundations. What we did at Lancaster was we cut out the slab and the foundations were down, I don't know, maybe 2 feet. So what that allowed us to do was cast a new foundation directly over the existing foundation and kind of encapsulate it. It was spread footings. And so we actually had the top of the new foundation, the new footing, be flush with the top of the slab. So it basically looks like the slab. It's got an isolation joint around it, and you wouldn't know the difference. So that's how we provided enough area to get the force into the ground without exceeding the bearing capacity of the soil. Or the rock in this case. So then it was a question of, okay, now how do we get the load into this new foundation? And what we did there was we added a bunch of fairly thick plates around the column on top of the new footing, and then added some stiffeners to those and welded them to the column. So we had this kind of built-up, modified base plate that basically just bared right on top of the new footing, bypassed the existing base plate that was now anchored in concrete. So that was easy. It was a pretty easy approach for the gravity load. Where it gets tricky is where you have uplift forces. So we had to add a new braced frame in this building, and it was a couple of former gravity columns that weren't designed for uplift. And so for those, we had to go in and cast a new footing, similar to what I was just describing, but we added micropiles to it to anchor it into the rock. So we found that micropiles are a great way to modify existing footings or add capacity, and especially for resisting uplift. And it was kind of cool. They brought they ended up there was part of the building that was demolished, a one-story wing, and so they were able to cut out part of the floor there and lower the drill rig right into the basement, and it was on treads, and they're just kind of able to drive it around down there and do what they needed to do. It was a pretty cool project to see.
Wow, that's pretty convenient. One thing that kind of blew my mind was that the structure remained open while construction was going. Was that part of the how you guys designed, or did it just end up working out well that way?
Little both, and that's not unusual for these kind of projects either. We did another one at there's a hospital down on Long Island where we added a floor to it, and same deal. They're pretty sensitive about shutting down hospitals for you to add floors to. I don't know why. So yeah, what's interesting is you have to be careful about things like hot work, and this is true not only for vertical additions but for something much simpler like a mechanical dunnage, and this happens all the time where we're putting we're not even doing the structural work actually. It's just say an emergency department renovation. They have to put a new air handler on the roof. Well, maybe the roof wasn't designed for that and we have to add a new dunnage. And so now it's a question of, okay, how do we attach the new steel to the existing steel? And, we'll weld it. But now we're talking about things like fire watches, and you're welding above a confined space, above an emergency department. So how does that work? And so those are things you have to consider. But the other part of it too, again, specifically to Lancaster, is adding the new floors. Okay, that's one thing. But then we also had a horizontal addition, two horizontal additions to this building. We added a bay in each direction. And one of those bays occupies an alley, really, between that separates this building from adjacent healthcare spaces. And like many hospitals, there's half a dozen bridges that crosses that and to provide traffic for patients and clean linen and soiled and all that kind of stuff. So we actually had to sequence the construction of that horizontal addition so that it didn't interrupt any of those bridges. So we actually built in sections around the bridges and then bridged over the bridges. And then a traffic path had to be developed so that the bridge could be taken out of service and traffic could flow to an adjacent bridge. Well, that bridge was demolished and the structure infilled and then reconnected and then reopened. And so we had to come up with a pretty elaborate sequencing plan for how the bridges would remain in service until the last possible minute. And then, so that traffic was never taken out of service between the buildings.
Yeah, so I assume in these cases, something as elaborate as that, you've got the contractor on board in the meeting, the client laying out a map of what is required when. I mean, this has to be pretty well planned out.
Yeah, that's exactly what happened. And in Lancaster, they were a great client to work with and still are a great client to work with. We're continuing to do work there now. We had Benchmark Construction, a part of that project. They were the construction manager, and they had worked on that hospital campus for many years, and so they were familiar with all of the nuances and existing conditions that we weren't as familiar with. And that's exactly what happened, is we all kind of sat down together and say, all right, which bridge has to remain operational? When can it go out of service? And that was, of course, a conversation with the client. And then it was a question of, okay, now how do we actually build this? And are we able to get, what's our crane reach and things like that? And so it was a matter of having all of the affected parties kind of sit down together and plan this out and sketch it out on paper.
Oh, that's neat. I want to ask about the Hawthorne Mall a little bit. I was flipping through some photos of that, and it just looked like a monster addition, both vertical and horizontal, to an existing mall. And I just wonder, what were some of the complexities of that project?
So with a mall, it's kind of similar to a hospital in the sense that it's open. Well, maybe not 24/7, but pretty close to that.
Yeah.
And one of the unique concerns about a mall is, just like a hospital, downtime is not something you can deal with. Mainly from a revenue generation standpoint.
Yeah.
So with Hawthorne, this was the addition of a new cinema complex to the mall, and it was partially located adjacent to the existing building, but also suspended over a big box department store. Again, I think another JCPenney. And it keeps coming up. And so part of the issue with going vertical above a mall is they are not designed for vertical expansion in any capacity. And so with going above the existing structure, it was kind of accomplished in two ways. The first was portions of the building are suspended, kind of hung from new structure outside of the footprint of the existing building above the existing building. The other part of it is we worked with the owner and looked at the existing structure and looked at the existing building and found the most strategic places to put some new columns that would minimize disruption to the existing building, but also kind of maximize the structural efficiency. Mm-hmm. And so we went into the mall complex and kind of cordoned off some specific areas within the stores, the occupied stores, performed the work off hours, and threaded, I think, like 9 new columns through the roof of the building, through the existing department stores, and to new foundations that, much like Lancaster, were micropile foundations that they were able to just install right in the existing structure. And so the new columns go right through the space in a place that doesn't disrupt the existing activity, through the roof. And then once they're above the roof, it's pretty much conventional steel construction work at that point.
And how are you tying in the lateral system in this case?
Well, we're not actually.
Really?
So it's a totally independent lateral system. So those columns are, in a sense, structurally isolated. They're freestanding columns through the building. They go through the roof, but don't attach to the roof.
Interesting.
And they're connected to the new structure. But the columns themselves are just gravity only. They're not a part of the lateral force resisting system. And those forces go through the diaphragms, the floor diaphragms, back into the horizontal portion of the addition. And in that particular building, it's a series of braced frames. So the advantage of the location there being Illinois, not a very significant seismic region. So we're mostly talking about wind forces.
And from a code standpoint, was that renovation done pretty much as a new structure? I mean, it sounds like
it was
totally independent. Yeah.
Okay. With both of these projects we've talked to, do you have any lessons learned that you'd like to share?
Well, I think with some of these, it's so specific to the actual project, but I think there's some big takeaways is that anytime you do any kind of renovation, whether it's a vertical addition, horizontal addition, or you're just, renovating a single room in a building, knowing what the owner's expectations are and knowing what your limitations are, that's probably the most important thing. That's really where you need to start. And the second thing really is just be prepared for surprises, because you really never know what you're going to find when you start getting into a building. So, example of Lancaster, actually, turns out all the columns were way out of plumb for the existing building. It was, so the existing structure, 3 stories, the first floor was 1974. The next 2 floors that were added to it were in 1979. And then, of course, we added what we added. But between 74 and 79, those columns were not put in straight. And some of them were off by like 2.5 inches sloping. So we had to consider that in our design and kind of resolve the forces that we were putting on the columns. So it was an eccentric load. And so that gets resolved in a force couple at each floor.
Right.
Which once we had the survey data, we had to check and make sure that the lateral system could handle the thrust from that, which it could. But so, you don't know what you're going to find once you get into these.
Wow,
and
that's wild.
It is, and but it's typical of maybe an extreme example, but it's pretty typical that you get some interesting things in some of these older buildings, and even not so older buildings.
Yeah, man. Yeah, when you said the out of plumb, the first thing I was thinking of is your direct analysis method, where you're assuming a little bit of out of plumbness on an individual based method, but that it doesn't sum to do anything to the building, right? But so when you were looking at this, you were, I assume, mapping this out where each column was, a portion of load and its horizontal component.
I think what I did was trying to remember. I think I did a recent model where I had I ended up modeling all of the columns with their out of plumbness, and then all of their gravity load on them to see one, how does that force get resolved at the floor? What's my thrust at each column location? But two, now do I have a problem where I've got a P delta situation and I've got bending stresses in those columns, and it had an impact, but fortunately, the one we were already reinforcing a number of those columns for the new gravity load, and that kind of took care of some of that problem for us.
Oh, that's super cool. As someone who's done a lot of existing structure work, do you think there's any common mistake that people make, or something that's just always worth double checking when you're, say, looking at somebody else's project?
It's the first thing that comes to mind is the lateral system. I don't know what it's like in your area, but there's a lot of existing buildings that were built well into the 80s in my area and in the East, where you look at it and it's like, I can't find the lateral system, and it in some cases just wasn't code required, or it just wasn't something people did. And so when you go in to modify these buildings, now all of a sudden you're looking at you have to question, like, all right, if I'm in a certain, if this becomes a level 3 alteration, then I need to upgrade the lateral system, and there's nothing to upgrade. So I guess that means I need to put one in. And now all of a sudden that has a whole cascade of consequences. The other thing is, and this is some recent work that we've been doing, change of occupancy. So if you have maybe a very simple building, but now you're putting something in, give you an example, a university that has a dorm building, right? A wood frame dorm building. It's clearly a risk category 2 building in most cases. But now if the university police wants to occupy a portion of it, does that make it risk category 4? And if it does, well, what does that mean? So that's another thing that I think can sometimes get overlooked, but there's no shortage of things. And, in my narrow experience, you talk to any engineer in our firm and in other firms, I can guarantee you they're all going to have different things to say about different lessons learned on their projects too. Yeah.
I feel like the old lateral system of a partially restrained moment connection it's not something I know very much about, but I feel like that's something that maybe was used a lot more many years ago, and it's a harder one to track down.
It is. I mean, you can still use it. It's still code permitted, but it's difficult to model in the sense that you have to really consider the rotational restraint at each joint. And so we're talking about springs and stiffness, and that's no fun.
I think that's all the project questions we have. Is that, Zach, do you have any others that come to mind?
No, I think we kind of hit everything I wanted to talk about with that. So John, kind of the way we end these is trying to give, we gave some good insight on existing structures and kind of talk through some of those processes. Is more of what can a new engineer do or think about to move forward to be successful. So in your opinion, what makes a good engineer, a good structural engineer, let's say?
Well, I think of structural engineering as, and this is something I heard from one of our engineers that I agree with, is that it's really just a more technical form of architecture. And I think that that's really where it starts, is having an appreciation for architecture and for design. Because, when you look at other engineering disciplines, specifically mechanical, electrical, and plumbing, we're talking about things that are, for the most part, within a building or part of a building. But for structure, it is the building. It's the building itself. It's just another side of architecture. The two can't exist without one another. And so I think for a good structural engineer really needs to think like an architect and try and anticipate some of the things that are important to an architect. And a lot of that can have to do with brace locations. It can make the decision of what kind of lateral force system you're going to use, whether a structure is going to be exposed or not. And I think that's the first thing. But then the second thing is, again, going back to what I said about, what it means to be living center design, is to, once you're in the mindset of the architect, to put yourself in the shoes of the occupant. You're going to walk away from this building when it's done, and and that's rewarding. But there'll be generations of people that interact with it. So how do the decisions you make impact the people who use the building and the people who own and operate the building? And what can you do to make their lives easier? So I think that's probably, if I had to pick one thing, that's really what it is. Those two things, I guess, are really, in my view, the most important things to keep in mind when you approach a project. And what's interesting is they're not technical things. I think most engineers in general come from similar backgrounds in that they like to build things. At least that was mine. Yep. Or they have an interest in math and science or physics or something like that. But beyond that it's kind of the softer side: communication, collaboration, those kind of things, understanding other people's point of view, understanding the user's point of view. I think that's what differentiates the best engineers, I think.
I want to cut in here. If you want to learn more about Canon's living-centered design ethos, they've got a great document on their website. Just head to canondesign.com, and right in the top center you'll see living-centered design. They've got a great PDF you can flip through, so I won't butcher it by trying to quote anything here, but it's worth checking out. For people that want to improve their communication skills, do you think there are good ways to do that?
Sure. Yeah, I think there's always ways to improve. I don't think you ever stop improving communication skills. We, again, going back to what I said earlier about our learning programs, the Canon Academies, a lot of them, there are a whole series about presentation skills, interview skills, things like that focus on the softer side. And whatever your firm offers, I think, is a great way to do that. But in colleges, technical writing is a huge part of it. Being able, I don't know, I always say I'm kind of a weird engineer because my favorite classes in high school were, English and history. So
really?
Yeah. So, and I'm still a history buff. So nice. and I enjoy writing too. So maybe I'm kind of weird, but any opportunity that's out there to take advantage, either at the college level or at what's offered in your company, to take advantage of that. And even if it's not a formal way, to be able to get up and practice talking in front of people, to be able to give a presentation, I think that's important, especially as your career goes on and you're asked to become involved in interviews or explain a complicated idea to a client, or explain why you need to rip up their floor, things like that. How you frame those things can often have a big impact on how they're received.
Yeah, that's wonderful. I'm glad that you guys address it in the Canon Academy. I think it's, with technical skills, there's just a trove of information online. You can look up anything, right? But I mean, certainly it's there for soft skills as well, but I think it's something that engineers focus on much less, and it's good that it's addressed.
Yeah, and it's, aside from the formal framework of it all, that is one of the big benefits of being an AE firm, because you do see how architects or non-engineers communicate, and you can pick up some things and you can learn from your colleagues. And beyond that, we have a very large communications group and graphics design group. And so being able to work with those people to put together articles and things like that, or to develop presentations, it's just a great resource for us to have. And, we're able to learn from the experts right in our own offices.
Well, thank you for joining us this week. We really appreciate you listening to us. We know you listen to us every week, but some of you aren't subscribed to us. We know you guys all need to tell your friends about us. It would really mean a lot to Max and I. All the emails and messages we get from you guys with questions is awesome. So keep reaching out to us, Instagram, Facebook, email, and we'll catch you next time.